Take a picture.
Okay.
Okay, I just answered. I think it's actually 4.6 because that's the one where it has exponential and logarithmic functions.
Okay.
So,
I'm still waiting for it to come through here. Huh, I wonder why it's taking so long.
oh, okay, maybe it didn't send. Oh, I think it's going to be enabled. Let me go to my settings. It is enabled.
Did it say it's sent?
Um, iMessages need to be enabled, but it is enabled. That's why I don't understand. Let me start. Let me fix it. Okay, messages. It's gonna work this time.
I guess you could try writing it up because I still haven't gotten anything yet.
Yeah, it's my phone. It says it's not sending it because iMessages are not enabled, but it's actually enabled, which is weird. Okay. Okay, 4.6. There's question 21 to 31 all. 21, it says solve each logarithmic equation expressed in the rational solutions in exact form and as a decimal rounded to 3 decimal places. So it has the log of 2.
It says the log, like 2 base down there.
Yeah, log 2 base x plus 7. Yes. Plus the log of the base 2 x plus 8 equals 1.
Okay. When you're dealing with logs, do you know what this plus sign means?
No, I do not.
Okay. when you're dealing with logs, if I want to take both of those logs and write them together, then plus means that I have to multiply the two things that are on the inside. So I'm going to
Okay.
consolidate this all into one log. So I'm only going to write log one time,
Mm-hmm.
and then I'm going to multiply these two things together. So it's x plus 7 times x plus 8. And then that's going to be equal to 1. That's how you go from two different logs into one.
Mm-hmm. But they have to have the same base, right?
They both have to
To
have the
match.
same base.
Okay.
Most pre-calculus questions, they never say like base 4 and base 2 or base 4 and base 8. They don't do that to you anyway,
Mm-hmm.
especially when you're just starting to learn it. So it's not something you're going to need to worry about, but it does have to be the same base. Now I'm going to use the exponential rule, which means that this number right here is my base. This number right here is the exponent.
Mm-hmm.
And then this right here just stays exactly where it is. So I'm going to
Okay.
take this number and stick it underneath that one.
So you make it into a different form. Okay.
I'm writing it into exponential form. So the log
Are
is
you,
going to disappear.
okay.
So I'm going to leave this stuff here. So this is x plus 7 times x plus 8. And then the 2 becomes your base, so it becomes a big number. And then the 1 becomes a little number, so it becomes the exponent.
Equals x plus 7, x plus 8. Okay.
And
That makes
now
sense.
and now I can solve for x. I have to FOIL this thing. So I'm going
Okay.
to do it quickly because we don't have a whole lot of time. So this is x squared plus 15x plus 56. And that's equal to 2. You see where I got that? Because that's just FOILed
Yes.
out. And now I'm going to set, this is a quadratic. So now I'm going to set that equal to 0. So I'm going to get x squared plus 15x plus 54 is equal to 0.
That makes sense. Okay.
And now I'm looking for two numbers that multiply together that give me 54, and then they add together to give me 15.
Okay. So I'm writing my products out. So 2 and what? Let me get my
Joy, can you go get the remote on the desk, please?
4.
Julian, it's over there on the desk.
3.
It's over there on the desk.
I think it'll be 3 and 18.
Um,
Well,
3.
it would have to be. No, never mind. Because it's positive. Positive.
So this is 9 and 6.
9 and 6 would work. Okay.
So then this is x plus 9, and this is x plus 6 equals 0.
Mm-hmm.
And then I'm going to solve. So this is x is equal to negative 9 or
X is equal to negative 6.
right. Now one of those numbers works and the other one doesn't. So we have to plug it back in. Because you know that the number inside of the log can't be negative. Right?
Oh, that's true. Yeah.
So if I plug in negative 9, well, actually, I guess both of them will work. So I'm going to plug into negative 9 into that. Okay?
Okay.
So I have the log of negative 9 plus 7 times negative 9 plus 8. And this is 2. And so this would be negative 2 times negative 1. And that's 2. And so I have the log of base 2 to the 2 is equal to 1. Is that true?
2. Okay. Yeah.
Yep, that's true. So now let's try negative 6. So I'm going to put negative 6 plus 7 and negative 6 plus 8. So in that case, I get 1 and 2. So I get the log of 2 to the 2 is equal to 1. So I get the same thing twice. So both answers are correct.
Okay. So you have to check it. You have
You
to put
have
it
to
back
check
in
it.
and check it.
You have to put it back in and check it because sometimes it won't work.
Okay. Let me see.
So do you know your 4 log rules? Did the teacher break those down to you?
Yeah. I do. I went over it last night.
So if this is a minus sign, then what do you do to the two things instead of multiplying?
Oh, okay. Wait. I don't know that part. No, I thought you meant the actual formula, like
Okay,
log.
let me go
Okay.
over all 4 rules then so you have them, okay?
Okay.
Because you're going to need to know them in order to do this. So I'm going to say the log, and it doesn't matter what the base is as long as it's the same, of x plus the log of y is equal to the log of x times y. That's the first one that we did. So that's the one we just used. If there's a plus
Right.
sign in between, you multiply the two things. It doesn't matter what they are, you just multiply them.
Gotcha.
If I have the log of x minus the log of y, then this is equal to the log of x divided by y. Whatever is negative, that's the one that goes on the bottom. So anytime you see a negative sign in front of a log, you put it in the bottom of the fraction.
Okay.
Okay?
So when it's subtraction, that's going to be your denominator, the log of y.
Right. So let me give you another example so you have it. So if I have the log of x minus the log of y minus the log of z, then you
Mm-hmm.
have two negative signs here, right?
Yes.
So the x is positive, so it's going to be in the top of the fraction. The y is negative, so it's in the bottom of the fraction. And the z is negative, so it's in the bottom of the fraction. And then you just write the log once.
Oh, okay. So you would have like y times z
Yeah,
for the denominator instead of like the z under y. So I
right,
guess.
right. It's y times z, and that's why I showed you that, because I don't want you making it more complicated than what it is. The negative sign
Okay.
just tells you to put it in the bottom of the fraction. That's all you need to know.
Okay. Gotcha.
Um, the last one is if I have the log of x to the y power. If I have the log of x to the y power, then I'm going to circle this part. When I rewrite it, whatever that exponent is goes in front of the log and gets multiplied. And you're going to use that a lot in order to solve logarithmic equations. So this
Okay.
is going to be equal to y times the log of z. I'm sorry, x. I meant to say x.
Okay. You're
Y
just moving it over.
log. Right, you're just moving it over.
Okay.
And then you're also supposed to know that the log of 1 is equal to 0. That's the last one.
Cool. 31. 31. Can we do number 31?
Yep, just tell me what it is and I'll write it out.
Okay. It's log base a multiplied by x minus 1 in parentheses minus log base a x plus 6 in parentheses equals log base a x minus 2 in parentheses minus log base a x plus 3 in parentheses.
X
Plus
minus,
3.
is it minus 2? X minus
Oh,
2?
yeah. Minus 2, yes.
And then what's the last one?
Then minus log base a x plus 3.
I didn't realize it was so long.
I didn't know either. But I figured that I'd get it if I could figure this one out.
Okay, so we're going to consolidate the logs first. So what does that minus sign mean?
It means division.
So I'm going to write
So
that as one log. So tell me how to write it.
so log base a x minus one over log base
No,
a
you only write
x.
the log. You only write the log once. You only.
Oh, okay, gotcha. Okay, log base a and x minus one over x plus six.
There you go. Okay, so do the other side for me.
Okay, is equal to log x minus two over x plus three. It's log base a. Okay, that's what I meant.
Okay, so here's the rule. You see how these two logs have the exact same base,
Yes,
and they're on opposite sides of the equal sign, right? They're on opposite sides of the equal sign, right? You heard me say that, right?
yes, I did.
When you see that, these two logs cancel each other out.
Okay.
So you end up with x minus 6 over x, sorry, x minus 1 over x plus 6 is equal to x minus 2 over x plus 3.
Mhm.
Okay, now we need to use something that we learned from last chapter. I need to figure out what the domain of each one of these things are before I actually solve it. So what
Okay.
can't x be here?
It can't be zero.
So what can't x be?
So x can't be negative six.
There you go. That's what I want. What about this part?
My computer is, hold on.
Okay.
It can't be, x can't be negative three.
Keep those two things in mind. So if I solve for it, I can't have either one of those answers. Okay.
Yes.
So the next thing that we're going to do is we're going to cross multiply.
Okay.
So this is x minus 1 times x plus 3 is equal to x minus 2 times x plus 6. Do you see how I got that?
Because you cross multiplied.
Right. Next step, we have to FOIL.
Okay.
So I get x squared
Plus
plus 2.
3x.
I'm going to do it fast. I'm sorry.
Okay.
I just skipped the middle step because I want to get through as many of these questions as possible. You can always go back and redo it.
Okay.
And then I'm going to do the exact same thing to this side. So this is x squared plus 4x minus 12. You see how there's an x squared there and there's an x squared there?
Uh-huh.
Whenever you have the same thing on both sides of the equal sign, they cancel out.
Okay.
So this is x minus 3 is equal to 4x minus 12.
Okay.
So 9 is going to be equal to 2x. And that means that x is equal to 9 over 2.
Okay. That makes sense. I mean, because when you're saying like when it's a across the equal sign, it's just basically saying you could say minus x squared, right?
Right, right.
Okay.
If you can remember that rule, it'll make the math easier because sometimes people tend to add when they should subtract, and that'll mess the question up. You know what I mean?
Yeah.
Because people make sign mistakes all the time. So that's why I tell my students that if it's the same thing, just cancel it out so you don't have to worry about the math.
Okay. Okay. That was it for 4.6. That's not. We didn't have any other questions. Oh well, 4. Well, 20. Okay, wait, never mind. Well, We've done these ones. I feel okay with that. Let's see here. In the problems 41 through 68, solve each exponential equation, express any irrational solutions in the exact form, and as a decimal rounded to three decimal places. What does that mean, the irrational solutions? Or?
Um, a rational solution means that you might have a square root or something in it. So they want you to show it in its exact form, and then they want you to like how I had that 9/2 in the last question. They want you to write it as 4.5 for the answer. So the rational solution was 9/2, and then the decimal solution was 4.5.
Okay. They have this problem right here. 8 negative x equals 1.2. Um, so you would change this to logarithmic form, right?
Yes, you are going to take the log of both sides.
Oh, okay.
Do you
How
need
would you
help
go
doing
about
that?
doing that? Because all I know is that this is this. I don't know. Simplified.
Okay, I'm going to make it easier than that. Can I erase that?
Okay.
I don't want to erase the whole thing. I just want to erase like the what you just wrote. So this is what I mean. I'm going to take the natural. Ooh, sorry. I'm going to take the natural log of both sides. Okay.
Okay.
Now that means that this number, I can use the last rule that I showed you of the 4. I can take this x and I can move it in front. Do you remember that rule?
Yeah, I remember that. Yeah, the
Because
y.
it used to be, sorry, this was the exponent, right?
Mm-hmm.
And so I can pick it up and I can just move it there.
Will it still be negative?
Yeah, I just didn't grab the negative sign the second time I grabbed it.
Okay.
Okay, this is just a number that you can find in your calculator. This is just a number that you can find in your calculator. So I can say that negative x is equal to the ln of 1.2 divided by the ln of 8.
Okay.
Do
Because you're trying to get negative x by
Because I'm
itself.
trying to get negative x by itself. And what is the negative x doing to that ln of 8?
It's dividing.
It's multiplying, right?
Mm-hmm.
Because it's right next to it.
Okay. Yeah, that's what they're doing at first. Yeah.
So
But then
that's why I
eventually
can
you'll
divide
divide.
both sides by the ln of 8.
Okay.
And then I can move the negative sign over to the other side too. So this is going to be x is equal to negative ln of 1.2 over the ln of 8. That's your rational solution. So now you
Okay.
have to stick that in your calculator in order to find out what that actual number is.
I got negative 0.0876. Should we just round it to like two decimal
Well, what
places?
does the direction say?
Oh yeah, they did give us directions. Three decimal places.
So there you go.
So negative 0.0877. if you round up.
That's 4 decimal places, right? So this would be 88, right?
1, 2, 3. Well, I 1, 2, 3. I look at the third one, and then I look because if they say three decimal, I just look at the one that's the fourth place to decide my third one.
So did you say this was 0.0877? Is that what you
Yeah.
said?
hmm
If I'm rounding to 3 decimal places, these are my 3 decimal places, right?
Oh, I'm thinking of significant figures. I'm thinking chemistry too. Okay, so 0.087. So it's gonna be 0.088.
Right.
Okay.
And you were right. That is 3 sig figs. You're right.
Yeah.
Are you taking chem too?
No, I took it summer one. That's why
Oh, okay.
my mind is still going there. But okay, I wanted to see what the answer was in the back. That's 4.6. See how they wrote it too.
And it's negative, right? Don't forget the negative sign.
Number 45. Yeah, negative 0.0888. Yeah. Okay.
So when you see something like the ln of a number or the log of a number, remember it's just some decimal. So it acts like all the rest of the numbers like 2, 3, 4, and 5. I know it looks weird, especially when you're starting to do these for the first time, but it's just a number. So all the properties that it has for numbers work. So like if I have two ln's multiplied by one another, I just find out what each one of the ln's are and I multiply them. It's just like 2 and 3. They're regular old numbers. They just look funny.
Okay. What about this problem? It says using a graphing utility to solve each equation, express your answer rounded to two decimal places. Oh wait, I think that's two. Well, never mind. Forget that one. Um. Okay. We can move on.
Okay.
I mean, they have one like where it's 2x minus. Maybe we should do this one. It's like 2x minus 5 equals 8. Can I try solving for this one?
Yes, you can try doing it.
So I would think that based on what we learned, you can put this in the front, right? X minus 5 over 2 log of 2.
You can do that.
And then what do we do with the other one? ln. Oh,
Well,
is
if
this
you're
is
going,
supposed to be ln? This is supposed to be ln too, right?
you can use log or ln. The properties are exactly the same, so it doesn't matter.
So log of 8. Okay. And then you're trying to get x by itself,
Mm-hmm.
so you'll divide.
Right.
So now you're left with x minus 5 equals the log of 8 over 2 over the log of 2, and you want to add plus 5. So you're going to solve this and then add 5 to it,
Mm-hmm.
and then do your decimal.
It's it's 8. The answer is going to be 8.
Okay.
I'm going to show you another way to do it. But what you did there, this thing is going to end up being 3. I'm going to show you another way to look at it, just so you have this in your tool bag, okay? But you did that perfectly.
Okay.
Okay. How can I write 8 as a power of 2? 8 is 2 to the what power?
2 to the third power.
Okay. So I just rewrote this, so I'm going to delete it. What do you notice about both of these bases?
They have the same base, so that means their exponents are the same.
Right? So that means that the bases kind of cancel each other out, right? So you're left with x minus 5 is equal to 3. So what is x equal to?
It would have to be 2.
How do you move the
Wait,
negative
no.
5? How do you move the negative 5?
Oh, plus 5, plus, I was being lazy, sorry. 8. Okay. I just wanted to, I don't know what I was doing. Okay, 8. Yes, of course. Okay. I did a lot of problems like that before when you have the base the same, then it equals each other. The U and the V equal each other, right?
Right,
That's what,
right.
yeah.
And that's literally called change of base. So you can actually change it to a number that you can actually use. But the way that you did it using logarithms is exactly the same thing. If you take the log of 8 and divide it by the log of 2, you're going to get 3.
Hello?
What are you doing over there, girl?
My mom, she came back from work. She's
Okay,
my brother went to open the door.
okay.
Okay.
Ooh, Lord, what are they doing up there? It's probably Julian doing backflips, literally.
Okay. There's another one. That's weird. Okay.
Okay.
This one right here. It's 16. Let me see. 16x plus 4x plus 1 minus 3. This is x plus 1 equals 0. So it looks like this is called solving an exponential equation that's quadratic in form.
Uh-huh. And that is a quadratic equation. Um, so how are 4 and 16 related to one another?
4, well, um, 4 times 4 equals 16.
Right? So that x is a what then? If I were to write that as its change of base.
The 16?
Yeah, the 16 changes to what?
4 to the 2.
Uh-huh. And then it's raised to the x, so that becomes 2x, right?
Yes.
And so that changes. This is the same as this. Trying to think about, do I write this as x squared plus x plus 1 is minus 3 equals 0? Or do I write this as, if I take the ln of everything, then that's going to be, huh. I know that that thing is squared. Hold on, give me a second.
Where did we get the bases to cancel each other out?
Huh?
How do we get the bases to cancel each other out?
I don't know with that 3 there. Give me 1 second. I don't know if I'm supposed to set it up that way or if I'm supposed to set it up as 2x plus 3x minus 1 equals the log of 3. I'm not sure which way I'm supposed to go, so I'm going to check my book.
Okay.
Okay, so this is how they set it up. So I'm going to do it the exact same way. So it's supposed to be set up just like this. That's what I thought. Because this thing is 4 squared,
Mm-hmm.
then that front term is going to be squared. So you have to solve this quadratic. So it's x squared plus x minus 2 is equal to 0.
Okay. And now you can solve for x.
Mm-hmm.
Oh, but how did we get rid of the 4? I guess that's the thing that I've been sticking to. Like, how do we get rid of that?
Those bases are the same.
Hmm?
I said those bases are the same, right?
Yes.
Because 16 is equal to 4 squared.
Right.
So if it's equal to 4 squared, then I'm going to square this x. That's how the
Okay.
bases go away. This is just a constant, so I'm going to leave the constant term there.
Okay. Okay. I see.
And so you get x plus 2 and x minus 1, and then x is equal to negative 2 or 1. And then I got to stick it back in to make sure I actually get the right answer. So if I take 2 times negative 2, so you get 16 to the negative 2 power plus 4 to the negative 2 plus 1 minus 3 equals 0. Let's see if that's actually equal to 0.
Okay. I got my calculator. I don't think so, but
Okay,
is it supposed to equal 0?
it's supposed to equal 0. I don't think that's going to work. So let's try the other one. 16 to the negative 1 plus 4 to the negative 1 plus 1 minus 3 equals 0.
So 4 to the 0 is 1, right?
Yeah,
Because
so that's
negative 1
1.
plus 1. So that would be 1. And then 16 to the negative
That's 1 over 16. I don't think that's going to work either.
minus 3.
3 minus 1 is 2, so this would have to be 2. Is that one in the back of the book?
Yeah, this one is 61.
Okay, so
They
look
have
at the back of the book.
all, let me check. 4.61. They have like log of 4 parentheses negative 2 plus the square root of 7 parentheses. It's so different.
Okay, let me try doing it the other way then. So we had 16 to the x. Was it plus 4?
4 to the x plus 1 minus 3.
Okay, so I'm going to still change this base.
Mm-hmm.
I'm going to bring the 3 over to the other side.
I texted you their example in the book. They're using u when they want to substitute the exponent, like when it looks funny. They're using the u for some reason. That's how they're doing it.
Okay, let me see. Oh, hold on one second. My computer's about to die. Forgot to plug it in.
Okay.
Okay. Okay, so what if I say that... Come on. What if I say that u is equal to 4 to the x? I'm going to rewrite this one like this.
Mm-hmm.
4x squared. And then I'm going to write this one like this. Plus 4x times 4 minus 3 equals 0.
Mm-hmm.
You see what I did there?
Right.
And then I'm going to substitute u in to each one of those. So this would becomes u squared plus 4u minus 3 equals 0.
Mm-hmm.
And then, you mean to tell me that doesn't factor? No, it doesn't factor. So now I'm going to use a quadratic equation. This is my a, this is my b, and that's my c. So it's
Mm-hmm.
negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 4 plus or minus the square root of 16 minus 12 all over 2a. Plus 12, sorry, plus.
So,
And
so
this is
two.
just 2.
Okay.
So
16 minus 12 is 14. Wait, no, that's not right.
it ends up being 28, right? Because I have a negative 3 here, so negative
That's
3
good.
times negative 4 is positive 12 times 1 is 12. So minus 4 plus or minus the square root of 28 all over 2. You see how I got that? Andrew, you with me?
I'm with you, but I don't know how you got the 28. But if
What
the
is what
math.
is what is 16 plus 12?
Oh, okay. Okay, no problem.
Got
I
it?
don't. I got a subtraction for some reason.
The negative 3 times the negative 4 makes it a positive 12.
Okay, I got it.
Because C is negative.
Gotcha.
So this would be the square root of 7, and this is the square root of 4. So then this is going to change to minus 4 plus or minus 2 root 7 all over 2.
Yes.
And then you get negative 2 plus or minus root 7. And that's the answer they have in the back of the book, right? Or do you have to
Oh
plug?
yeah, that's what it was. 'Cause I said that. Yeah. They actually did the decimal form, so I think they went ahead and rounded it to 3 decimal places. So it was like -2 plus area root of 7.
So that form that I wrote there, that's called the rational form, by the way.
Okay.
And so we do all of that to find out what u is. So minus 2 plus root 7 is equal to 4 to the x. And then you have to take the log of this in order to solve for x. It's the log of that and the log of this, which brings the x down here. I'm just running out of space. So I have x is equal to the log of 2 minus negative 2 plus root 7 all over the log of 4.
Okay. Gotcha. That's what they have. Hello?
Yep, yeah, oh, sorry, yeah, I'm agreeing with you. Yeah.
Can we do asymptotes? That he does a lot of problem. I know that will be on the exam for sure. The
Sure.
asymptotes. It says find the vertical asymptote of any of the of any and graph each rational function. And then there's one with horizontal or oblique asymptotes. If any of the following functions.
Okay,
Um,
do you know your 3 rules for horizontal asymptotes?
I'm gonna be honest with you, no.
Okay, give
I think
me.
he wrote it here. It says H is greater than M, no horizontal asymptote. If H is equal to M, horizontal asymptote equals Y. I mean, I don't know it, but I wrote it down.
Okay, let me give you real world stuff that's not math speak. Okay,
Okay.
so all I want you to do is focus on the powers of the
Okay.
leading term. All right.
Okay.
So if I have f of x is equal to x to the 4th, and then it's plus a whole bunch of stuff over x to the 5th, and there's a whole bunch of stuff there. Okay. Where is the exponent bigger?
The exponent is bigger on the denominator.
So when the exponent is bigger on the denominator, the horizontal asymptote is equal to 0. That's all you need to know. If the power is bigger on the bottom, the horizontal asymptote is equal to 0.
Okay.
Here's the next one. What if I have f of x is equal to x to the 4th with a whole bunch of stuff over x to the 2nd?
Well, it's bigger on top.
It's bigger on top by at least 2, so greater than 2. You see how the power is bigger by 2?
Mm-hmm.
Then that means that there is no horizontal asymptote. Okay?
Because it's not on the bottom, right?
Because it's not on the bottom. It's bigger on the top by more than 2. So as long as the exponent is bigger by 2, the difference between these two things is bigger than 2, then you have a
Mm-hmm.
horizontal asymptote. You don't have one. here's the next part. Let's say I have 3x to the 4 with a whole bunch of stuff, and then I have 2x to the 4 and a whole bunch of stuff. What do you know about the powers?
They're equal.
So when the powers are equal, the number in front of the highest term is going to tell you where your asymptote is. So your horizontal asymptote would be equal to 3 over 2.
Okay.
So when the power is bigger on the bottom, it's 0. When the power is bigger on the top by more than 2, there isn't one. When the powers are the same, then the horizontal asymptote is whatever the coefficients are in front. Here's the last one.
Okay.
F of x is equal to, let's say this x squared plus 2x minus 1. I'll put plus 1. And then I have x minus 3.
Okay.
What do you notice about the difference in power here?
Well, 2 is 1. This just has a 1 power, so that's less than.
So this gives you an oblique asymptote. Or it's called a slant asymptote, depending on the teacher. So in order to find it, you have to do long division. So I'm going to show you this. So I'm going to put x minus 3 on the outside, and then I'm going to put x squared minus 2x plus 1 on the inside. Do you know how to do long division?
Not really.
Oh,
But I
Lord
can.
Jesus. Okay, I'll write it up quickly. So, because we only have like 2 minutes. So I have to make this term and the front term the same. So I'm going to multiply that by x. So x gets distributed to both of those.
Okay.
So this is x squared minus 3x. Then I change the sign. So this becomes a negative and that becomes a positive. Those two terms cancel, and then I'm left with x here. And then I'm going to bring this number down. So it's plus 1. And then I need to make this term and this term look the same. So I have to multiply it by 1. So this is plus 1. And then I multiply it again, so I get x minus 3 here. I change the sign. So this is minus, that's plus. Those cancel. And then I'm left with a remainder of 4. So this is going to be plus 4 over x minus 3. The remainder part isn't important. This is where your slant asymptote is. This is your asymptote.
Mhm. So you have to solve these kind of problems. You have to be able to do the division, because I think I saw that in one of our examples.
Yeah, to solve that kind of problem, you have to be able to do long division to find the slant.
Okay. How would you graph all this? Where?
Okay. So let's talk about vertical asymptotes. The vertical asymptotes is completely determined by the bottom term. So what can't x be equal to?
X can't be 0.
So what? Okay, the bottom can't be equal to 0. So what can't x be equal to?
On X minus 3.
X minus 3 is not equal to 0. So I need you to do the step for me.
So it can be equal to positive 3.
There you go. So that's one of your asymptotes, and x plus 1 is the other one. So if I were going to graph that, I'm going to have to erase some of this.
So an asymptote, is it telling you this is your border, you can't do this?
Right. It's telling you where you can't cross.
Okay, gotcha.
So if I'm going to plot this, I'm just going to clear all of this off. You can actually go back and look at the video because I'm taping this now.
Okay.
So I have a line at x is equal to negative 3. 1, 2, 3. So I'm going to draw a dashed line there. that is my x is equal to -3. So that's my vertical asymptote. My slant asymptote was y equals x plus 1. So it starts off at 1, and the slope is up 1 over 1. So it's going to look like that.
Mm-hmm.
And now I just stick in some points to figure out what side of those lines it's on. I think it looks like this. So that would be your f of x. And this would be your f of x. I probably should have drawn a center line.
So the y equals x plus 1, is that an asymptote as well?
Yeah, it's, you see this dashed line here? Y,
Mm-hmm.
that dashed line is y is equal to x plus 1.
Okay. That wasn't the original problem.
Right. The original problem was this, was f of x is equal to x squared plus
2x plus 1.
2x minus 1, was minus 1, right?
Oh, plus 1. Plus 1.
Plus 1. And then it was over x minus 1 or plus 1?
Mm-hmm. That's -3.
Minus 3. Okay.
I was just wondering, how'd you get the linear from that quadratic on top?
Do you remember when I divided, when I did the long division?
Yeah.
The
Oh,
front
yeah, yeah.
the front two terms gave me the slant asymptote. That's what I was showing you. That's why you have to know how to do long division.
Okay. And what makes it a slant asymptote is if the bottom, the top is plus 1 of the bottom.
Right. The power difference is 1.
Okay. So you're okay. Okay.
We just went over a whole lot of stuff. Are you gonna be okay?
Yeah. I need to take a break and go back and try the practice problems. But at least I have an idea, right?
Right.
No, that's better than nothing.
I'm going to put the video up as soon as we get off, so it should be posted in the next 30 minutes, and I'll add it to your playlist. So you can go back and review all the stuff that we just did if you get stuck on a question.
Okay, sounds good.
You can do this in one of two ways. I can change the invoice that I sent you yesterday to 1, or you can just pay both of them right before we work together the next time. I don't care which way you do it. Doesn't matter to me.
I can pay both the next time for sure.
Okay.
Yeah. Thank you so much.
You are
I know it
welcome.
was last minute. It was just yesterday was so hectic and
Is everybody okay?
it was. I was having some car issues that were just like and starting a new job with car issues.
It's never good, right?
It's not good. And I was like, oh Lord, I'm trying to be reliable.
I'm sorry.
Yeah, but it's gonna be all right.
All right. Well, good luck on your test. Let me know how it goes, and then I'll see you sometime soon.
Okay, thank you.
You're welcome. All right. Bye.
Bye.